Today let's use serial bus servos with Arduino. As usual, you will see a circuit, source code and several working demonstrations. I will use LX-16A servo motors. This servo model is in the robot that you might have seen on this channel. As a development board, I am using Adafruit Metro. It is an Arduino UNO clone, so all the pins are the same. And the most important thing, you will get a new serial bus servo library for Arduino that I recently released. If you like the libraries and tutorials I am creating, please subscribe and support me through a link in the description. Now let's begin. Alright, this is the complete diagram that includes all necessary components we need to control serial bus servos with Arduino. One of them is this small white board, which is called the BusLinker. We need to connect it to Arduino through 3 wires. TX pin of the board should go to RX pin of Arduino, RX pin should go to TX of Arduino, and GND to GND to create a common ground for our circuit. An external power source should be connected to the BusLinker to power our servo motors. It could be anything in the range of 6 to 8 volts, but I think these servo motors will be able to work if you provide only 5 volts, but their performance of course will be much lower. 5 volts pin of the BusLinker could be left unconnected. To connect servo motors, use Molex cables that are typically included. Typically these servo motors come with those cables and you just connect them to the BusLinker and to servo motors. As you can see, it is convenient to connect these serial bus servos in a chain so that you don't have to extend wires from each servo to the board. And that's very convenient for robotics. For instance, you can imagine that you have a leg or an arm that is quite long, and you can just connect these servo motors one to another. They have pins. Servo motors have ground voltage and the signal pin. And the job of the BusLinker is to split this signal into RX and TX. Without that, if you connect serial bus servos directly to Arduino without the BusLinker, you will not be able to use certain commands. For instance, you will not be able to read any values from these serial bus servos. So that's all for circuit. Okay, let's look at this easiest program that we can use to control serial bus servos on Arduino. It is called Simple Servo. I'm using LX-16A bus library and I need to include it into my project. For that, I need to search it in the library manager and install. It's already installed in my project. It's called LX-16A bus. There is another library in the library manager, but that library doesn't support the BusLinker. So if you are using BusLinker, we need to install this library. Let me click More Info and go to the libraries repository. Here we have the complete documentation that has description of all methods, and also it contains examples that we will go through in this video. Now we are looking at simple servo example. So let's go back to our file. I create instances of motor classes, servo motor classes LX-16A. Then I initialize them, set them to servo mode. In the main loop, I simply command these motors to go between 0 and 240 degrees, which is the minimum and the maximum angle they can go. Let's compile, upload and run this program. This is our simplest example in real world. You can see that this motion is quite abrupt, and we will solve that in the next examples. There is one tricky thing about programming these serial bus servos on Arduino. Let's look at these errors. You see, it cannot upload the sketch to the board. This happens because when TX and RX wires are connected, this uploading cannot work. So every time before uploading your program to the board, remove these TX and RX wires either from the Arduino or from the BusLinker. Our next program, print info, reads several parameters from servo motors and prints them to the serial monitor. I read voltage using getVin. I read temperature using getTemp method. I'm reading isMotor mode to get whether our servo in motor mode or in servo mode. If it's in motor mode, it can rotate 360 degrees constantly without be able to stop at specific angle, and it just rotates at certain speed. If it's in servo mode, you can command it to go to a specific angle between 0 and 240 degrees. Is torque enabled? This method reads if torque is enabled on the motor, and if yes, you cannot easily rotate the motor with your hand because it will resist rotation. Is LED power on? You can see how it looks in real life. So it's whether LED on or off. So in the program, I turn it on or off. And finally, these are just functions to print Nix robot logo. So let's compile and see how this program runs. Let me launch a serial monitor. Alright, so it reads different parameters and prints them, like voltage, temperature, mode, torque. The next program is very basic. It just sets an ID of a servo motor using this setID method that accepts an integer number between 1 and 253. All LX-16A motors come with the default ID 1, and to distinguish between them in your program, you need to assign a specific ID to each of them. This ID is stored in the permanent memory of the motor, so assign this ID only once and then just put a physical label on the motor. In the next example, let's make something fun. Let's build a sinusoidal oscillator with our servo motors. To achieve that, I created a special sinusoidal oscillator class. This class and this example, of course, is included in the examples in the repository, and this class contains these methods: start, update, and is running. Is running just verifies if the oscillation is running or ended. Start method begins oscillation, and the most interesting one is update. It updates this function every 50 milliseconds, moves to the next step of the function, and it uses sine function, and it also depends on the maximum angle provided. This update method is non-blocking, so in the main program, in the main loop, it does not use this delay function. It just reads time value in milliseconds and calls the update method of each oscillator, so that in the main loop you can execute any other commands, any other functions you want without it. This oscillation doesn't block everything. That's the very nice and elegant solution. And in the main loop, what happens in the main loop, it just begins oscillating. If oscillation doesn't happen, it updates oscillator every time, and it changes the maximum angle at certain points. So let's look how it works in the real world. Now this is how oscillation works in real life. You can see that rotation begins slowly and stops slowly, and it goes from the maximum angle to the smallest angle, but also it changes its amplitude, because in the class that I created you can specify the amplitude of this oscillation. In the next example, let's try motor mode, and it will be a smooth motor. I created an additional class for this example so that our motor will slowly begin rotating and slowly stop rotating without abrupt motion. You will see that in the demonstration. As usual, I am creating instances of my servo motors, instances of smooth motor class, and then I initialize everything and set my servos to motor mode. When I set servos to motor mode, I need to provide the speed value, which could be from -1000 to 1000. Why -1000? It's for the rotation to the opposite direction. So I start rotating and I set the target speed to 1000, but in the main loop I call the update method, and it will not immediately begin rotating at 1000 speed. It will slowly start rotating and achieve very quickly it will achieve that speed and will continue rotating at that speed. Then I will command it to stop. In my case, it's after 2 seconds. I will command my motor to stop. Then I will command it to rotate to the opposite direction, so minus speed. I change the sign of this variable. In the smooth motor class, let's look what methods we have. We have start, stop, update, and is running methods. So they are similar to what we have in oscillator. The difference is that in the update method, it's not a sine function. It's just a linear function, just a linear increase or decrease. And the step is 25 or -25, depending on the direction and what we are doing, starting or stopping. And I update the speed every 25 milliseconds. This is how it performs in real life. So you see that these motors start rotating not abruptly, but they increase their speed and then they decrease their speed. In the last but not the least, and actually the best example, which is called smooth servo, I'm using my servos in servo mode, and I command servos to go from one angle, which is their current angle, to a target angle, and do that smoothly without abrupt motion. So it starts its motion slowly and it ends its motion slowly. How did I achieve that? let's look at this smooth servo class. I use this function to calculate its intermediate angle. Let's look how it looks in a graphic calculator. For instance, I want to start from 0 and go to 1. And here you see, if I go from 0 to 1, I slowly start and slowly stop. And if I want, for instance, go to a different value, for instance 2, the pattern is the same. It could be also I can also go from 2 to 0, and also the pattern is again the same. So no matter what values I use for my current angle and my target angle, it will be the same thing. And you will see that how it works in real life. It's very nice, very smooth. Let's go back to our code. In this class, again, we have start, update, and isRunning method. So I already explained how the update method works. It just calculates an intermediate angle using this function. And in our main program, we again create instances for these classes, for our servo motors, for smooth servos. Then in the setup function, we initialize everything and set servo motors to servo mode. Then in the main loop, I command motors to go from 0 to 120, then to 240, then back to 120, and then back to 0. And it repeats this cycle. For that, I use these very complicated ternary operators. You don't have to use exactly this code. You can create your own program. It just shows the principle. So let's look how it works in real life. This is a physical system demonstration for smooth servo, and it's the best example. You can see that it's similar to Sine Oscillation and smooth motor example, but in this case you have the full control. You can command servos to go from any current angles to any target angles. And it is very good for robotics, because in robotics you want to avoid abrupt motion, so that a robot doesn't fall or doesn't damage anything, doesn't damage itself. If you like this video, please consider supporting me. The link is in the description, and subscribe to this channel. Thank you for watching this.